Here we have a problem in trigonometry. Okay, let's go to the question. Find the principal solutions in degrees of the equation 2 sin square x negative 3 sin x positive 1 equals to 0. Okay, in this equation, in this trigonometric equation, we have the variable x. Since x is being a part of the trigonometric function sine, when I solve for x in this equation, I'll be getting an angle measure as solution. And also I have to get that angle measure in degrees. And also the question says find the principal solutions. What is meant by principal solutions? When I solve for x, the angle measure I'm getting for x must be in the interval 0, 360 degrees. So when I get the angle measure for x in this trigonometric equation, and when the x is in this interval, so it will be considered as principal solutions. So whenever I'm solving for a variable in a trigonometric equation and I want to find a principal solution, so the value I'm getting for the variable must be in this interval, so that it will be considered as a principal solution. Here in this interval, we have the left side closed but the right side open. That means 0 degree is included, but 360 degree is not included. So that means the value of x has to be 0 degree less than or equal to x less than 360 degree. That is, x can be equal to 0 degree or greater than 0 degree, but x has to be less than 360 degree. So why we include 0 degree and why we don't include 360 degree? Now let me draw the four quadrants. So here we have 0 degrees, here we have 90 degrees, here we have 180 degrees, here we have 270 degrees. So I started moving from 0 degrees. When I come over here, I finish one full rotation, then we'll have 360 degrees over here. We have both 0 degrees and 360 degrees at the same position. Since both of them we have at the same position, we ignore 360 degree. That's why we use parenthesis over here. Parenthesis means it's open interval. That is 360 degrees should not be included. Okay, now what we can do is we can start solving the given trigonometric equation over here. Okay, my first step, what I'm going to do is I'm going to write this sine square x as sine x whole square. That is, equation will become 2 times sine x the whole square negative 3 sine x positive 1 equals to 0. I have written the sine square x as sine x whole square. Now, to make the solving process easier, I'm going to assign a new variable y for this sine x over here and here. So let y equals to sine x. So when I assign the new variable y for sine x, then 2 times this sine x whole square will become 2y square negative 3 times. Instead of this sine x, we can write y positive 1 equals to 0. Okay, now look at the equation over here. Now it's a quadratic equation, the variable y. To make the solving process easier, I have assigned the new variable y for the sine x. Now our aim is to solve for y. Once we solve for y, we can replace y by sine x, and then we have to solve for x. Okay, let's try to solve this quadratic equation by factoring. For that, we have to multiply the constant term positive 1 by the coefficient of y square 2. When I do so, I'm getting positive 2. Now what I have to do is I have to get two factors for this positive 2, so that the product of the two factors equals to positive 2, and the sum of the two factors is equal to the coefficient of y, that is negative 3. I think negative 2 and negative 1 will work. When I multiply negative 2 and negative 1, I'm getting positive 2. When I add negative 2 and negative 1, I'm getting negative 3, which is the coefficient of y. Now we have to divide both these factors by the coefficient of y square. So that is 2. When I divide this negative 2 by 2, I'm getting negative 1. So we cannot divide this 1 by 2. We have to keep this one as it is. Okay, now to get the first value of y, I have to change the sign of the first factor over here. So here it's already negative. If I change the sign, it will become positive. That is y equals to 1. And to get the second value of y, I have to change the sign of the second factor over here. It's negative. When I change the sign, it will become positive. That is 1 over 2. Okay, now I have solved for y in the given quadratic equation. I got two values for y. Now we can replace this y over here and here by the original stuff sine x. So when I do so, I am getting sine x equals to 1 and sine x equals to 1 over 2. Okay, now we have to solve for x in these two equations. For that, let me consider the four quadrants. So here we have 0 degree, 90 degrees, and here we have 180 degrees, here we have 270 degrees. Here we have quadrant 1, here we have quadrant 2, here we have quadrant 3, here we have quadrant 4. And also we can consider the ASTC concept, that is we have A in the first quadrant, S in the second quadrant, T in the third quadrant, C in the fourth quadrant. Usually we write ASTC, and we can remember this one as all silver teacups or all students take calculus. Actually, we have the first letter A for the first quadrant, second letter S for the second quadrant, third letter T for the third quadrant, and the last one C for the fourth quadrant. So we have A in the first quadrant. That means all trigonometric ratios, sine, cosine, cosecant, secant, cotangent, tangent, everything is positive in the first quadrant. In the second quadrant, we have S. S means only sine and its reciprocal cosecant are positive in the second quadrant. The rest are negative in the second quadrant. The third one, tangent and cotangent are positive. The rest are negative. In the fourth quadrant, cosine and its reciprocal secant are positive. The rest are negative. Okay, here in both the equations we have sine, and in both the equations we got the value of sine as a positive. Here positive 1, here positive 1/2. So that is the angle measure for, let's consider the first equation over here. So here the value of sine x is positive 1. Since this is positive, the angle measure I am going to get for x over here will be either in the first quadrant or in the second quadrant, because in these two quadrants sine is positive. In the first quadrant, all trigonometric ratios are positive. In the second quadrant, the sine and its reciprocal cosecant are positive. So in the third and fourth quadrant, we will not be getting angle measure as a solution for x in this equation, because in the third and fourth, the sine is negative, but here we have positive. So now we have to get the angle measure, that is the value of x in the first quadrant and the second quadrant as well for this one. Okay, and also let me consider the quadrant angles over here. The quadrant angles are 0 degrees, 0 degrees, 90 degrees, 180 degrees, and 270 degrees. These are all called quadrant angles. And here there are two horizontal quadrant angles and two vertical quadrant angles. So these two are horizontal quadrant angles and these two are vertical quadrant angles. Now let me consider the values of sine and cosine on the horizontal quadrant angles. So the value of sine 0 degree is 0. And the value of sine 180 degrees is also 0. So when I consider the horizontal quadrant angles, the value of sine is 0, and the value of cosine 0 degree is 1, and the value of cosine 180 degree is -1. Here on the vertical quadrant angle 90 degree, so the value of sine 90 degree is 1, and cosine 90 degree is 0. Let me write it. Cosine 90 degrees equals to 0. Okay, here on this vertical quadrant angle 270 degree, the value of sine 270 degrees is -1, and the value of cosine 270 degrees is 0. Okay, when I look at the angle measure from 0 to 360 degree, for which we have the value of sine is 1, is there is only one angle measure from 0 to 360, there is 90 degree. So for the angle measure 90 degrees, the value of sine is 1. So solving this equation on the interval that is 0 degrees, 360 degrees. So we get only one value for x. X is 90 degrees. Okay, now we have solved this equation, that is sin x equals to 1. Now we have to solve for this equation, that is sin x equals to 1/2. Okay, now let me erase some stuff over here and continue the problem. Let's continue. Now we can start solving the second equation over here, that is sin x equals to 1/2. In this equation also the value of sine is positive. Since the value of sine is positive, we'll be getting an angle measure for this x in the first quadrant and the second quadrant also. So let's get the angle measure for x in the first quadrant over here between 0 to 90 degree. I think we can use either unit circle or trigonometric ratio table to get the angle measure x, for which the value of sine is 1/2. So when I use unit circle or trigonometric ratio table, I'm getting x equals to 30 degree. So when this x takes the angle measure 30 degree, the value of the trigonometric function sine is 1/2. Okay, now I got an angle measure in the first quadrant. Okay, now let's get an angle measure in the second quadrant, because in the second quadrant also the sine is positive. Okay, now to get the angle measure in the second quadrant, what we have to do is we have to use this 30 degree is as reference angle over here in the second quadrant. Let me do it. So here we can take the reference angle 30 degrees that we got in the first quadrant. And now to get the angle measure over here, what I have to do is I have to subtract this reference angle 30 degrees from this 180 degrees. There is 180 degrees, negative 30 degrees, which results 150 degrees. So 150 degrees is the angle measure in the second quadrant, for which the value of sine is 1/2. So the second value of x for this equation is 150 degrees. Okay, I got three values of x, so let me list out the values over here. So 90 degrees, 30 degrees, 150 degrees. So let me write the smallest angle measure, 30 degrees. And the second one is 90 degrees that we got over here. And the third one is 150 degrees. So when I solve the given trigonometric equation, I am getting three values for x, 30, 90, 150. All these values are in this interval from 0 to 360 degrees. So all these values of x can be considered as principal solutions.